shapes that completely covers the plane with no gaps or overlaps. Describe the symmetry of the design by identifying as many transformations as you can that carry the pattern onto itself. Be precise. Draw lines of reflection, points of rotation, and vectors of translation right under the drawing and label them clearly. Okay, so first let's start with reflections. I had it cut it out, so if you need to reflect it, it would look somewhat like this. See, if you do this, it doesn't look right. So what you have to do is you have to reflect it across this line and then reflect it again across that line, and then it lines up with it. So that would make this line a line of reflection, then this one, and then of course it would go across this one, that one, same along with here, and then if you have it here, you need to reflect it over to this one. You would do the same thing that way, and then reflect it. So across there, right? So then that would make that a reflection line all the way along here. That one, just like before, this one, that one, that's one, and then you would have one. You need to reflect this to here, same one there, that one. Now if you need to reflect over to this one, you'd have to reflect here, so I'd make this one right here also, and then you would have to go across this way also, so all this way. You have to do a double reflection. It's not just a normal reflection. So there's the reflections and then the translations. So it's here. You need to get it here. You just kind of slide it. So really an easy way of doing this, show it, is like this, because it can go that way, that way, that way, that way, that way. Pretty much every which way to get to the other shape. So there, this one, that one. Of course, go that way. And there's other ones, but that'd go off the page. So then let's do a rotation. Rotations aren't as easy. So you have, show with this. So you can go like this. You can, if you need to go this way, you can rotate it and it still lines up. You can rotate it on this point, it lines up. Rotate it even again. So it's pretty much each corner of the shape. So you get each corner, but it's only the corner of the shape. So there's one. There's a lot of them in this one. I think that's it. So these are each. Then you'd want to go, so the reflections equal, draw a line, and then you do, since you used orange for reflection, you want to make sure you label that by going like that. Then translations, and then you use this, and then for rotations, you just go. Geologist with the first human colony on Mars is using a robotic rover to collect mineral samples. Since magnetic compasses do not work on Mars and Mars has no GPS satellites, the rover navigates by counting turns of its wheels. The rover was pre-programmed with a route and should be returning to the prospecting base by now. Unfortunately, the rover cannot be seen from which it is expected to come. After a quick consultation, the geologists discovered the problem. The robot handler started the robot 90 degrees in the wrong direction. The robot should have been headed to the east when it started. Instead, it started heading out to the south. The display below shows the robot's planned route and its navigation program. The readout shows that it is currently executing step 14, a turn to the right. On the digital map, S marks the robot's starting location. The square cursor marks the location where the rover would be if it had started on the right direction. Okay, so now we need to find out. So A, on the map, use the X to mark the robot's actual location at the end of step 14. So if it started out south, south would be down here. So now we need to follow these. Forward 2000. So this would have been step 1. The turn would have been step 2. This would have been step 3, right here. 4 would be the turn. 5 would be the straight. 6 would be the other turn. 7, 8, 9, 10, 11, 12, 13, and then the right would be the 14 here. So now we need to find out. So now let's measure it. So it's like 3/8 of an inch. So now we go 3/8 of an inch south. So that's the way it started. It's about right here. Okay. So then we do 2, which I would mean it would have turned this way because the robot would have been facing this way. So turn, and then 3 forward. So that would be this one. So we measure it. This one's about what is it? 1, 2, 5/16. So now we go like this. Go out 5/16. 1, 2, 3, 4, 5. So right there. So we did this guy. We did the right, forward. Now we're going to do the left. So left would be this way. Then forward, which would be step 5, forward 2600. So now we measure that, which that's 1, 2, 3, 4. So half an inch down. 1, 2, 3, 4. Right there. Right there. Okay. And then 6. So we're done with that. 6 right 90. So we'll be going this way now. Forward 1600. So now we're on to step 7. Forward 1600. So now we measure this. Let's use the inches side. It's about 5/16, just like it was earlier. So now let's measure that. 5/16. 1, 2, 3, 5. All right there. So then we have left. So that would be this way. Then forward 1500. So that's this distance. So now we measure it. It's just a little bit less than 5/16. Here we go. 1, 2, 3, 4. A little less than 15 or 5/16. Then we go right. So that'd be this way. And forward 16. So that's 5/16.
Doesn't matter. It's in the food. It's final.
Then we do right 90. So that'd be this way. And we go forward 6100. So that's this big long distance. 13. So that's 1, 1 3/16. So now we have to measure that. So 1 3/16. So it says use an X. So here's where it would be at the end of step 14. Done with those two, because they would turn right, so it'd be like this. So that's what it is, and then it says B. Fortunately, it is possible to change the robot's navigation program remotely by sending new commands to the rover. What changes should the programmer make to the robot's navigation program so that the robot will return safely home? So pretty much all they need to do is, since it's already facing this way, they just need to go and use step 15, because the 48, that's the same as this distance here. That's the 48. So if we measure that, so that's about 15/16. So if we measure that starting here, that ends right at the starting point. So pretty much step 15, they just follow it. It'll lead them back to the starting point. And then it will be facing the right direction. And they can go through the program again.